Okay, so today I have a quick problem where we're solving a line integral using the fundamental theorem of line integrals. And so basically a quick way to state that is, if we have the integral of a f dot dr type integral, and it is on a closed path, not a closed path, but is conservative, we can just evaluate a potential function of f at the end minus the beginning. So basically what we need to do is we need to find a potential function of f. Okay, so our big F is equal to negative sine x minus y, comma 1 minus x. Okay, and what our potential function is the gradient of little f is equal to the field big F. Okay, so we can come down here. So by our gradient, the partial derivative of f with respect to x for our big F is going to be equal to negative sine x minus y, and partial derivative with respect to y is equal to 1 minus x. So the way you want to start this, to cancel this, we want to integrate this function with respect to x. Okay, so this just becomes little f, and integral of sine is negative cosine, but the negative cancels, so we get cosine x minus yx, because y is a constant, plus some constant, but here's where it changes from a plus c, but it's a c of y. Okay, so note we have our potential function started, and we know this, so now we need to take the partial derivative of this with respect to y. So the partial derivative of this with respect to y, cosine x, that is just a constant in this case. Derivative of negative y to the x just becomes negative x plus, we'll just call this c prime of y. And note we know this, so this is equal to 1 minus x. So our x is canceled, so we get c prime of y is equal 1. Now we can integrate this with respect to y to get our c of y, which is equal to y plus some constant that will say k. And note, we can use k equals 0 for f. So that will get rid of that. And now we know what our little f is. It is equal to cosine x minus yx. And now that we know what our c of y is, just y. And now we're just going to want to evaluate this at our two endpoints. So we need f of 2 comma 5, which is equal to cosine of 2 minus 10 plus 5. So it's just equal to cosine 2 minus 5. Now f of 0, 0 is equal to cosine 0 minus, we don't really care because that's all just going to go 0. Cosine of 0, as we all know, is 1. Okay, so now cosine of 2 minus 5 minus 1. So this becomes cosine of 2 minus 6. And that is the answer